So, this week's topic is open source, but very specifically, open source in application and infrastructure monitoring. What do we mean when we say that? There's a lot of open source technologies out there. There's frameworks for your applications, there's a ton of projects for various specific capabilities. Open source in the area of monitoring generally means how you get data in to your monitoring platform, some of the standards and protocols related to that, as well as interfaces and potentially the monitoring tools themselves. So, open source technologies are not synonymous with free. I think that that's what a lot of people think. They can be free, but there are always costs associated with implementing and maintaining anything open source. And for some enterprises, this comes in the form of technical debt and tribal knowledge. So putting the notion that open source equals free can often, especially in the enterprise, guide you down a path that may not be the most ideal for your long-term strategy and could potentially cause problems. Also, it's not free because you have people inside of your team investing energy and effort into it. So, when you start to think about the technologies that you use to better support and monitor your infrastructure and your applications, you need to build a strategy around it. So, you can't just say, we like open source, so we're going to do open source because there's pros and cons of both. You should consider open source in your monitoring support functions, which is getting the data into your monitoring platform, standards and protocols for that data, and potentially dashboards and as code and integrations into your monitoring platform because there's a lot of possibilities to build plugins, integrations. Those can all be open source. Some platforms you can even code the configurations of the monitoring and observability platform itself. Those are the monitoring support functions. And we think it's very reasonable to consider open source technology there where you're confident in the backing of the project, the governance around the project, etc. Where we do not recommend open source is in the monitoring and observability tool itself. And the big reason for that is that your engineering team should be investing energy in utilizing the data inside the monitoring platform, not maintaining it and all the configurations associated with it. And also, it's a moving target. So you don't want to chase, like we've already seen this with the evolution from monitoring to observability. You don't want to always be chasing these new practices that your engineering team is demanding because that will ultimately slow everybody down and decrease the ability to have observability across your entire stack. So it is a judgment call. It is certainly a strategy, but we really want enterprises to focus on getting value from the data and not spending time on how to maintain and collect that. With that said, there is a lot of amazing monitoring support open source tools. And some of these, Splunk specifically, is committed to and invests a lot of energy into. And that one of those in particular, Dave is going to jump into, which is OpenTelemetry. But there's a lot of amazing projects out there to support getting better quality data into your monitoring tools and also having nice standards around that data so that you are not locked in by the data collection process itself. So before I kick it over to you, Dave, any input you wanted to add to what I said?
So I've been adding a couple of things inside this. One of the things that's kind of important, and to emphasize what Chris said, is open is not free. Neither is free. And when you come to software, there's always an underlying cost inside of here. The other thing that is pretty important to consider is not just the project, but the maturity and the support of the project itself. Since you're no longer You're no longer necessarily getting to have a single throat to choke with a company, and it's very hard to hold a community responsible. So be sure that the project that you're interested in is ready for the use as well. So what I want to talk about a little bit is one of our major open source projects on OpenTelemetry. One of the things that Chris pointed out is that getting data in is something that shouldn't ever be locked into a closed format. In fact, it probably shouldn't even be locked into a closed agent or collector model. Data is the driving force for observability, which is where the market is going to. And while we could spend a lot of time talking about what observability is, I want to sort of jump into what data collection kind of needs and why we think that open source is the right way to approach this. So, looking at this from a data collection viewpoint, we sort of come down with five basic principles that fall into place when we're trying to get data in GDI. First of all, we think that the collection of the data should be standards based. And standards can fall into multiple categories: de facto, which is because everybody uses it, or de jure, where it's a force of law, such as an ISO standard or an ECMA standard, one of those type of things here. But we believe that data should be available from all sources to any source. And this is something that is more and more the underlying principles of solid open projects here. I also think there should be automated code instrumentation so that person doesn't have to go in and manually build their code. And again, open source wins here because with an active community, lots of people contribute and lots of people build these things. So it's no longer the responsibility of a small group to build this. You can actually have experts that are building a Java auto instrumentation or a .NET auto instrumentation and then bring them into play here. We also think there should be support for developer frameworks, how people make use of this. And any code at any time should be accessible to this. We also believe that cardinality plays a major role in observability. And so, again, using the principles of open source, if it's an itch, somebody needs to scratch it. We see that cardinality has no limits as we move into an open source world. So, OpenTelemetry, which you probably heard a lot about, is the combination of open tracing and open census. And these two projects both were very mature projects. Open tracing has been part of the Cloud Native Computing Foundation for quite some time. OpenTelemetry came out of a consortium based off of Google's work here. The two were trying to solve basically the same problem. How do we get data in? In particular, how do we get tracing data in? Tracing data also contains metrics, so metrics came along for this as well. So last year, they merged together. They formed OpenTelemetry. OpenTelemetry is a cloud native compute platform as well. And interestingly enough, it is becoming an incredibly rapidly adopted method for, again, pulling in the data that we need to be able to resolve our system problems and our infrastructure problems. So when we look at this telemetry, it breaks down into sort of the verticals, if you will. These are the classes of data that we bring in to solve problems. And we talk about tracing, we talk about metrics, and we talk about logs. It doesn't mean we can't reach out beyond those, but that's where most of these pieces start here. And then we need those APIs for every language of interest here, canonical representations for every language of interest, and then how with the data itself is brought in. Is it a collector? Is it a sidecar? Is it manual capabilities inside of here? And then how do we work with the rest of the world? Because we're not operating in a vacuum. Interestingly enough, the CNCF open approach makes this easier. And so we now can see that we have lots of languages under development. You can see that we have lots of collectors and sidecar models emerging, and we're supporting lots of interop formats. So, talking about this from a real quick viewpoint, this is the second most active project in CNCF today. It's only exceeded by Kubernetes, which started in 2015. The last time I looked, there had been, not counting the individuals, but 149, I think, companies who have made contributions to improving open telemetry. So OpenTelemetry breaks down into the categories: the APIs, the SDKs, software development kits, and the data specifications themselves. It builds a collector, which is how we receive, process, and push data to other sources here. And it has client libraries, which are the vendor agnostics. How do we instrument to get these pieces of data in here? Most recently, we've added the capability to add logging to this. So logging is an early incubating stage for this. And right now, we're at beta for traces and metrics. What we heard at KubeCon in November is that they hope to go GA for both traces and metrics before the end of 2020. So the collector would be there, Erlang, Go, Java, JavaScript, and Python will probably all be there about the same point in time. We already have implementations for .NET and for Ruby, with auto instrumentation rapidly approaching those pieces as well. So the reference architecture is pretty straightforward. There's an application running on a host. The host can be virtual, the host can be someplace. And you have a collector, or in a term, an agent. And that agent can send data to multiple sources. The application has a library, either auto-instrumented or as a library that you do need to connect in, that talks to the agent that sends data. And it can send data, it could send the metrics only, or it could send the traces and metrics. And in the near future, it could send traces, metrics, and logs. That then talks to the service side collector. And the service side collector pulls this all together and can send it again to other pieces. So you can either have it as an agent approach, or you can have it as a service approach. And this gives you the flexibility to design how you want your data to move into your backend. Note, there's no mention of what the application needs to be, no mention of what the host needs to be, no instrumentation of any pieces other than that you're sending data in that open standard format to where it needs to get to. We are using things like the W3C, another open standard approach here, trace context. It's built off of B3, which goes back into the early days of tracing. The tracer kind of gets the context inside of here. It has the spans, which are the calls inside the trace, and there are attributes that are associated with every one of those pieces inside of here. You can sample. We don't necessarily agree that sampling is a good approach because then you lose data. Part of our job is to answer questions that we didn't even know to ask the question for. And sampling can eliminate the ability to answer those questions here. And if you look down here, one of the things is that we not only want to be able to bring data in, but we want to be able to push data into whatever format is of interest. And so OTLP, which is the OpenTelemetry protocol, or Jaeger, Prometheus, bringing the data in and out from those things are part of the tracing basics. Metrics, very simple. It's basically what we're using to record a measurement here, and then we can roll those up, aggregate them over time periods, and be able to look at the data that's involved inside of the metric spaces as well. There's also a nice thing, semantic conventions. Semantic conventions are things that are built to this that are basically standard ways of approaching the structure of what we're trying to monitor here. And they can include your environment. Is it in a cloud? Which cloud is it in? Is it making use of a particular computing instance, a host? Or is it a deployment service, such as we're going to watch Kubernetes inside of here? Or is it a container, a process, a serverless function? All those things are built into here so that we can represent across all of the environments what the resource looks like. This gives us a common vocabulary, a common language for all of our data coming in. So we don't have to necessarily guess at what the data means. We understand what the data structure means before we get to it. Heavily powered. One of the underlying principles in open source development is that we all do speak a common technical language. And the semantic conventions give us that functionality. Logs are incubating, and logs are near and dear. I come out of a log search background myself for this. The data model is impressive. It's very solid, and it's designed to map to existing log formats as well as be semantically meaningful here. Part of its underlying goal is to be able to map between log formats where it's possible. So bring logs in from one source in one form and export them out to a different form with the same semantics being carried through. And in fact, it should be possible to go from log format A to log format B back to log format A with no loss of data inside of here. We recognized three sorts of logs here: system formats, things like syslog. We're never going to change syslog. Syslog is the same across systems. So we support that directly here. Third-party application enable change the underlying log structure. We may be able to tweak it, but things like Apache itself or Nginx or the Oracle databases, we can't change the logs they put out. We may choose which pieces we see. Those third-party applications are also supported. And then the logs that we have absolute control over, but are not necessarily standard to us, first-party applications. The logging specification and the development focus and drive all three of those aspects so that we can meet all of the needs of the logging structures. Now, everything really is based around this collector. And the collector is vendor agnostic. And so you'll see vendors offering certain functionalities, but it also, again, be sure that they haven't tweaked it just enough so that it becomes open code unique to them, where it stays as open source and it's available to everyone. So it has the capability of looking at reasonable defaults. Put it in place, it should simply be able to start bringing data in. If you need something unique, you can adapt to that here. It should be highly performant. The early days of testing against this shows that it is massively performant. That data is available under the OpenTelemetry GitHub. It's a little dated at this point, but the numbers are impressive into what the application performance looks like here. And then it should be extensible, be able to customize without touching the core code inside of here. And then a single code base that supports all of those classes of data. So why do you even want this thing? Well, this gets you away from the application. And yes, you can manually instrument an application, but that means that every time you change the application, you're likely to change your underlying manual instrumentation here. So we want to get that away from the application. And so we want to be able to pull other things. We're sending data. Let's compress the data. Let's make sure it's encrypted. Let's pull things out of the data that are useful to the direct source, but should not be part of our monitoring source. And then we want to drive things like redaction or retry capability, not lose data. That's really bad. And so we also focused on, for the collector, the time to value. How fast can we get it up? How agnostic to languages can we make it here? And we want it to be as easy as possible to set up and walk away and get the data that you want. So the architecture from the collector viewpoint. There's a number of receivers that come in place. So the collector has receivers, and the receivers bring in protocols. In this case, I'm looking at the three I mentioned before: OpenTelemetry's protocol, Jaeger protocol, Prometheus. It also has exporters, and those exporters can export into other ones. This is not a comprehensive list of receivers or exporters. You need to go and find out what the status is, again, on the CNCF, and get an OpenTelemetry website that will give you the latest up to date. In the middle are processors. They can be batched, they can queue, retry, all the various pieces. You can have as many processes as necessary so that you can actually speed up the flow and make it elastic. And then your flow can go all the way through from an OpenTelemetry protocol and then be exported as a Jaeger protocol. If your backend is Jaeger, great. If your front end is coming in OpenTelemetry, great. So this gives us this translation ability within the collector itself. Likewise, we can bring the data in and send it out in multiple formats. There's nothing that says it has to be a single pathway. So we can bring data through, again, from OTLP and send it out to both OTLP and to Prometheus, as an example. Then we can have extensions that go into here. So we can keep track of the health of associated functionalities or what the actual performance is looking like. So part of our roadmap is to move our clients to beta as soon as possible. and to get our GA for traces and metrics done here. We really are focusing on tagging for or tracing for auto instrumentation for all the languages that we can. And we want to have the initial log support going into beta this year. Not totally sure we're going to make that one for here. Our documentation has improved and it will continue to improve. It's pretty impressive for any open source project to look at the quality of the documentation that OpenTelemetry has brought to the table here. And then we're focused on adoption. We're seeing adoption really begin to take off. And we're seeing adoption not just in the vendor community, but also in the end user community. More and more of our end users are looking at OpenTelemetry as the way to break a data controlled lock-in approach. And then we have an underlying goal, which we've talked a little bit about here, is to make sure that our getting started is as easy as possible. If it takes too long or is too hard to set up, it's not going to happen. And so we have an underlying goal as part of this community to make sure that it's easy to do that. So to sort of sum up here, observability drives this thing, this evidence-based debugging approach. And debugging is always an iterative process. You start with a metric. We drill down and look at the data and the observation pieces, and then we make the right deductions. OpenTelemetry is powering the new solutions to all of this. And OpenTelemetry is powering that new solution to observability.